Okay, so we're going to start with example 4, and there's a huge section of coordinate geometry, all right, in this chapter. So in example 4, it says, determine the coordinates of the intersection of the diagonals of parallelogram FGHJ with the following vertices. Okay, so the key here, I think, is we want to sketch out this parallelogram, and we don't know exactly, all right, what it's going to look like. I mean, you could draw a coordinate plane if you wanted to, but I just want to kind of eyeball what I'm looking at, okay? So I'm just going to quickly sketch a parallelogram, and then I'm going to label my vertices, but the thing is it doesn't matter where you start, but you do have to go in order, all right? Meaning, if I start down here at F, I need to make sure that I'm going in the order that they're giving me up here, and I'm going to go clockwise. So I'm going to go F, G, H, J, okay? This is just so that we can envision what sides are opposite of each other, all right? What sides are adjacent to one another, and then also what our diagonals look like, okay? And I'm going to give you an example in just a second, all right? But if I'm looking at my diagonals, because that's what it says in the prompt, all right? My diagonals are going to be segment GJ and segment FH, all right? So I have segment GJ and FH are my diagonals in this picture, okay? Now, you don't have to draw this next one, but I do just want to show you it doesn't matter where you start it for the vertices, because if you look, so I start in the bottom left. Let's say I start up here, all right, the top left, F, G, H, J, and I'm looking at my diagonals again. They're still going to be F, H, and G, J. Okay, so they're not changing anything depending on where you start. You just have to make sure you go in the order that it gives you, okay? Same idea is like if we're looking at opposite sides, GH is opposite of FJ here, all right, and same idea, GH is opposite of FJ. So nothing's really changing. We're just kind of getting a lookout of what sides are opposite of one another, and then, you know, what angles are opposite of one another, etc. Okay? But either way, what I'm looking for in this prompt is my diagonals, all right? And more specifically, I'm looking for the coordinates of the intersection of those two diagonals. So I'm looking for this coordinate right here, okay? So let's go up, all right, real quick and talk about what do we know about the diagonals of a parallelogram. So if we go back up to these properties, right here, all right, the diagonals bisect each other, and that's going to be key here, all right? They bisect each other. And what we know about bisecting is that they intersect at the midpoint of the segment, right? That's what bisecting means. So what I'm going to do here is I'm going to find the midpoint of the diagonals, all right, and they should match. So I'm going to look at the midpoint of GJ, and just to double check my work, I'm going to find the midpoint of FH, and I'm going to see if they match, okay? They should match because it's a parallelogram. So if we just do a quick recall, our midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Okay, so finding the midpoint of GJ, all right, I'm going to have 3 plus a negative 3 over 2. Comma, 5 plus a negative 4 over 2. All right, which would give me a 0, comma, 1/2, all right, as my point of intersection, okay? Let's just double check and make sure that FH is the same so I know I did my math right. So for FH, it's going to be negative 2 plus 2 divided by 2, comma, what is it, 4 plus a negative 3 divided by 2. All right, which gives me 0, comma, 1/2, which is exactly what it should have happened. So my answer here is just simply 0, comma, 1/2, all right, as my intersection of the diagonals. Okay, so I am going to go down, all right, here to this other coordinate geometry, and then I'm going to do a couple of the proofs that are on here, okay? So for this coordinate geometry, this one, I actually give this one as kind of like a bonus, not a bonus question, but a challenge question in class, because I like to see how students are going to problem solve on this, okay? So it is going to be a little bit longer, all right, of a process. All right, so let's go ahead and once again sketch out our parallelogram. Remember, it doesn't matter where we start. I'm going to start with A, B, C, D. Okay. So it says parallelogram ABCD has the following vertices. All right. Determine the coordinates of vertex D if it is located in quadrant 3. Okay. So once again, I didn't necessarily, all right, draw this correctly. All right, but that's fine. All right, because I'm just using this as a sketch. Okay. So if you take a look, I'm only given 3 of those points. And a lot of students, they try to do distance, all right, and that doesn't really lead us to anything. They try to do slope. That doesn't really lead us to anything. And I'm going to tell you guys what we're going to do here is we're going to do the midpoint, all right? And we're going to talk about how is that helpful. So once again, I'm going to draw in my diagonals, okay? And I know that this point, all right, is a point that both BD and AC have in common, okay? Because this point, let's call it E, all right, is the midpoint of AC and it's the midpoint of BD, okay? So can we find what point E is using the information that we're given? And we can, because we have A and C, all right, to help us. So using AC, we're going to find the midpoint of AC to tell us what that coordinate of our midpoint is, which is E, okay? So the midpoint of AC, we're going to do -3 plus 3 over 2, comma, 5 plus a -4 over 2. All right, which means that my midpoint is once again 0, 1/2. Okay. So that point E is 0, 1/2. Now, we are going back to chapter 1 on this. All right, you guys have actually tested on this, okay? How can we use this midpoint and this point B to find the missing endpoint of D? And what's going to be super helpful for us is that original midpoint formula I gave you guys, which is MPX equals x1 plus x2 divided by 2. And MPY equals y1 plus y2 over 2. I love this question, okay? So let's take a look at what we're given, all right? What we have right now is B, which is 1, 2. And we now have point E, which is 0, 1/2. Now what I'm going to do is I'm going to label my B as x1, y1. And I'm going to label my E as MPX and MPY. Do you guys see where I'm going? What I'm trying to find is point D, and point D is going to be x2, y2. So I'm going to plug in to my MPX and my MPY formulas in order for me to find my point D, which is x2, y2. Okay? So my MPX is 0. So I'm going to have 0 equals my x1, which is 1, plus x2 divided by 2. So solving this, I'm going to multiply both sides by 2. All right, obviously 0 times anything is 0 is equal to 1 plus x2. I'm going to subtract that over, and I'm going to get my x2 is equal to -1. Oops. Okay. All right, now I'm going to plug 1/2 into my MPY equals, my y1 is 2 plus y2 over 2. I'm going to solve. I'm going to multiply by 2. I'm going to multiply by 2. All right, that cancels out my denominators, and I'm left with 1 is equal to 2 plus y2. I'm going to subtract out my 2. And I'm also going to get my y2 is equal to -1, which means that my point D is -1, -1. Okay? Love that question. But let's just double check real quick, because it does say determine the coordinates of vertex D if it's located in quadrant 3. Okay? So if you guys just quickly remember, this is going to be real quick. All right? Quadrant 3 is 1, 2, 3, 4. Right? So if I graph -1, -1, that would lie in quadrant 3. All right? which means that my answer is correct. Okay. All right, come back for proofs in the last video.